Johnson with 10-5, the Pythagorean Theorem. Today we're going to be able to learn how to use the Pythagorean Theorem, and this is abbreviation for theorem, and learn about Pythagorean triplets. Alright, let's get a few vocab words down. What is the Pythagorean Theorem? Well, the Pythagorean Theorem says a squared plus b squared has to equal c squared for all right triangles, where a is the shortest side and c is the hypotenuse, the longest side. And that would leave b being the middle side. The Pythagorean triplets, what are those? Well, triplets are three whole numbers that satisfy a squared plus b squared equals c squared, like 3, 4, and 5. If we do 3 squared, we get 9, 4 squared is 16, 9 plus 16 equals 25, which is 5 squared. Alright, and the hypotenuse is a fancy word for the longest side of a right triangle, and it's always directly across from the right angle. And we'll put these a little bit more into practice in our examples. Here we go, example number 1. Find the missing side length of the triangle. And it is a right triangle. We've got our little right angle. We've got one side is 10, one side is 24, and our hypotenuse, this longest side across from this right angle, is c. So we're trying to find c. Oops. Alright, and remember a squared plus b squared equals c squared. So we get to just substitute in our numbers. Well, a is 10, it's our shortest side. B is 24, it's the other side. And c, we don't know, it's our hypotenuse. So we substitute them in. So we're going to have 10 squared plus 24 squared equals c squared. Well, 10 squared is 100, and 24 squared is 576. So we do our exponents first. Now we add them together, and we get 676 equals c squared. We don't want c squared. We want just c. So to work backwards from something being squared to not being squared is we need to take the square root of each side. So we're going to find the square root of 676 and the square root of c squared. Well, the square root of 676 is 26, and remember they can be positive or negative, and the square root of c squared is c, because c times c is c squared, and 26 times 26 is 676. Now, can we have a negative length of something? No, we can't. So the value of c is really 26. Alright, that was how to find our hypotenuse. Let's do another example. Let's find the missing side length of this triangle. And we got 7 is one side, 15 is another side, and we don't know this one. Well, we got to figure out, taking a look at the triangle, looks like 7 is our shortest side, so a equals 7. 15 is across from that right angle, so 15 is our c value. That means b is our unknown. So we'll use our Pythagorean theorem. So we'll set up 7 squared plus b squared equals 15 squared. Squaring our numbers, we get 49 plus b squared equals 225. And in order to solve this for b, we got to get b by itself. So we got to get rid of this 49. So we got to subtract 49 from both sides. That way we're left with b squared equaling 176. Again, just like the last problem, we don't want to know b squared, we want to know just b. So we got to take the square root of each side. When we do that, we get b, and this one is not a whole number. So we're going to use this curvy equal sign, which means about. So b is going to be about 13.27. And we'll go ahead and if we don't have whole numbers, let's round to the nearest hundredth spot. So b is going to be about positive or negative 13.27. And since we can't have a negative side length, b is going to be 13 positive 13.27. The last one, determine whether 9, 12, and 16 can be the sides of a right triangle. Well, if they are a right triangle, they will work in the Pythagorean theorem. So we got to try 9 squared plus 12 squared equals 16 squared, which is 81 plus 144 equals 256. That math does not work, so it's not the sides of a right triangle. If the math did work, it would be a Pythagorean triplet and the sides of a right triangle.